Hello everyone and welcome back. In this video we're gonna go over the two-line kernel design pattern, so stick around for that. Alright, so let's do a quick visual representation of a two-line kernel is, and I don't want this, I want a square. And let's, for the sake of argument, say that even though it isn't, all of this square here is a scan line. Like I said, this is just for representation, doesn't mean it actually is. Change colors. And what you always want to do is to update our graphics, our player, missiles, and our playfield within this horizontal blank. Of course, that's it's going to be really hard to do, but that's the point of the design pattern. And one of the good ways to do this is to do the two-line kernel. So, for example, we might let me bring my arrow over here. So here we update our, let's say it's even up to here. Our code goes all the way up to here. So we updated our display screen. Actually, let me say over here even before this. I'll actually go back over here. Okay. Out of the display screen up to here, and then let me switch to yellow, and from this point all the way to this point, which is the on this scan line, we're gonna load the values for the next line right over here. So then you're gonna update that line somewhere over here, and then let me bring back the blue color, and then from this point all the way over here we're gonna fetch the level for the ones below. So if you notice over here on this line, I have all the information. I load all the registers and values and store it. So now it's beginning to draw. And right over here where it ends, right over here, let me change another color. Right over here it ends. So then I'm just gonna fetch the values for the next line right over here. So it's fetched, and we're gonna start all those values over here. And then over here ends again, so I'm fetching these values for the next line that'll be over here, all the way down here. So let me just switch to the code and show you guys, because I think that makes a little bit more sense than this, but let's get to that part. Alright, so let's get started. We have a new material to follow with. We pretty much all gone through most of the material of the Dave forum that we were using before, and now I switched to the SpiceWare blog, which actually he made a game, the Atari 2600, right over here, and he's gonna go through the most of the process. Of course, I'm gonna put all the links on the description, and we're gonna go over the two-line kernel. And if you remember from the video representation video, all we're gonna do is update, like it says right here. Gonna update player and then the playfield, and then the next line you're gonna update the opposite player and the playfield, and so forth. So let's go down over here. So here's make a little more sense. You're gonna update player, which is pretty much gonna store the value. So store to graphics player 1. The playfield, and then you're gonna pre-calculate the player 1 on the second line. It's gonna jump, and you're gonna do the exact same thing, but this time for player 1. So we're rotating, and if you notice over here, let's go actually a little bit down, because if you, and here is the human graphics from his example, which is right over here. If you notice, the height is actually 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you come over here doing any of these graphics, you're gonna notice that's actually twice the size. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's already at 10. So this is probably double. And that is because with this two-line kernel method, they're pretty much doubling the size of our sprites. Because if you think about it, you're pretty much storing player 0. You're gonna pre-calculate player 1. then it's going to store player 1. So because this is still in the same state on line 2, we're pretty much doubling our sprites in order to compensate to store all your information within one scan line. So that's one of the things that we have to keep in mind when using the 2-line kernel, is that's going to be a little bit bigger than you plan. So just keep that in mind. And of course, he goes over here using the do draw method. And if you come over this do draw, which is highlighted, he goes over here. Where is it? Oh, here it is. All right, highlighted. And see, he calls do draw, which is almost exactly the same as the skip draw method. If you remember, the skip draw method is actually almost the same as this. This is using the illegal opcode, decrement and compare. Excuse me. And the only has do draw, and here we have the load a with 0. Well, let's just go over here, because he's commented over here. And here we have a 2C. This is a 2C, and this is the opcode for the instruction byte with the absolute address. So what it's pretty much doing is going to take 2C as the opcode, and then you're going to need two more bytes for the instructions, since it's absolute address. So the size of this is 3, and the size of that is going to be this load a with human pointer over here. So it's pretty much just going to change the status flags that we have, and you're just going to skip through this part. So that's pretty much one of the only difference. And over here, like I said, using the illegal opcodes. For most of the instructions in material that I found, pretty much everybody uses this DCP. So I'm pretty much gonna go with the flow as well. I read it, there was 3 safe illegal opcodes, and this is one of them. The other one was load A and X, and the double NOP. That's what people are considered safe. So I'm pretty much gonna use this one as well. And the other thing I wanted to talk about is .byte2c. I know I saw somewhere on some forums. I don't have the link right now, but I heard that it doesn't work on some supercharged cartridges, and in some forms of we have our bank switching. So this might not be the best possible solution if you're planning to use any one of those, but it's gonna work if well, the only thing you have to make sure is, like, it doesn't explicitly say which one of the bank switching are, but we can test it out. And of course we go over the different ones. He has the switch draw, the skip draw, which is the one we saw. And here we have the flip draw, which, doing a little bit of research, I found this 8-bit workshop, which is the creator of this making games for Atari 2600. And here is go over the whole thing. And if you go over here, already having a complex scene, which is, he uses another method to draw the lines. So it draws sprites, which doesn't require the Y counters. So I believe that's the flip drop, because it doesn't require a line counter. And if you go over here, right over here, as you see, modify this illegal opcode that we have over here. That's increment and subtract right over here, and he commented it out. And as you see over here, we're loading the sprite height, which is in 2 lines. Then you have your sec for subtraction, and go to do draw, and then you notice it doesn't actually require a line counter. So that's one way. Another way you can use the, instead of the skip draw, you can use this one. So we have a lot of options over here. I just recently purchased the book. I'm not gonna go through most of the, probably not gonna go through this material of the book. And here we have a bunch of other stuff I'm probably not even gonna cover it. So if you want some more information about it, you can come over here and look it up. And of course, all the samples are here, so we know enough just to look at the code and figure it out a bit of ourselves. But you know, it's always good to support other people that has the same interest as us. So that's another way to do it. So let's go over here and let's try to put that in our code. So let's open this up. Here I have my blank code as always. And the only thing I have done over here is put in this player and enemy sprites that I have over here. And now we're gonna go over our 192 and use this method over here. So let's do some copying and pasting, or maybe not. Let's just start over here. So first thing you have is a human height. It has all the prerequisite data that we use right over here. So here it does this human height, this really good thing over here. So here we're gonna put player height. So come over here. So is this, yeah, since this player height, which is equal times minus player. So what this time is pretty much like the current lines. So I can do this and it works fine. So this is the current location minus, so my current location minus the start location over here. So I could in chance just go over here instead of this put, I just could put enemy minus player. But then we're gonna do the same thing. So let me put this back over here. And the same thing over here, enemy height, which is, so the current location minus the enemy location, which is the start of this location over here. And here I'm putting all capital letters for constant values. It's a good practice you have it. And now we have our heights over here. Let's go over here and store those values. And let's go back to the code. Okay, so we have that. Let's start with this area height over here. And here it has 0 for 89. If you remember from what I said, the sprites are double the size from 10 to 20. The same thing applies for the playfield, except on this demonstration, because he actually every line he's drawing either everything on or off to have this line up. To have this line just to demonstrate the difference over here. But you're gonna load. So if you load a playfield from, and even over here on this display, you'll see there's 2 lines over here, like bigger, because you not only your sprites are bigger, so is your playfield if you're loading from a table. Here's starting manual. That's why it's every other line. So, oh, not over here, not yet, Alice. So let's have a arena height, and this only arena height is 180 because I think he leaves this space for the counter for their pointers over here. So let's go to your code. Let's do our constants right over here, and let's name it grain size, and half of 182, so I think it's 96. And we're going to load screen size, if I can spell size. Alright, so now let's do something different. Instead of this, let's put a subroutine just to change things once in a while. And you can call this kernel or main. I'm gonna call it main since I like it main. And now let's do a area loop over here, dot area. I'm giving some space like this, and we're gonna do so load a with not human player size. I should have just copy and paste you. So -1 because it starts with 0, and then we're gonna do our illegal opcode over here, -1. So TCP with human draw. I'm gonna call this player draw, and this player draw is actually gonna be a variable. So let's create that. .u var for variable org, oops, 80. So player draw ds .byte 1. So now right over here. And what else you have over here? So we have the branch to draw, do draw. Yeah, so branch of carry set to do draw player 0. Otherwise, I believe it's load a with 0, and then by QC. By QC. So now let me copy this. Remember to put a point over here. Let's draw 0. Let's see, it's right over here. And then here we're gonna have to load the human pointer. I'm gonna call it player pointer. Load a with should I no, it's not a const. Player pointer and then y. And let's go over here, and you're gonna need to create a player pointer. Player pointer, and a pointer is a memory location, so it has to be a word. So 1, or you can put 2 over here. It's your choice, or yes.byte. But I like to have this 1. And right over here, play pointer, and here we're gonna do our wsync. It doesn't matter what value it is, as soon as you store it over there, it's gonna give you a wait sync, and then you're gonna start a value that we have in player 0 into your graphics player 0. And then we're gonna do the whole thing again over here. I believe, you can always check if I did it right. So here's gonna be enemy size, and here's gonna be enemy draw, and of course I have to create enemy draw as well. So this player, just gonna copy, paste, enemy. Alright, sorry for the edit, but let's go back to the video. So I added the player draw and the pointers and the enemy as well. So let's finish off this. So now that we have this, we're gonna need to do the drop player 1. So I'm gonna do that. Do exactly the same thing. And let me fix this. put it over here. Okay, now it's prettier. And let me just copy. Let me just copy this area over here. No, it's gonna be the same. Here gonna be the ending pointer. And here we're gonna start to the graphics one. And I think we're done. So decrement y and then branch while plus through the dot area. So now let me check if I got it here right. Let me go back over here. We don't have any playfield, so it's right. And let me just assemble and run, see if everything's working. Source is not resolved. Let me go all the way down. Let me clear this. Assemble. Players. I think I know what the problem is. It's not player size or player height. Just go, here it is. Actually, just put size over here. Player size, why not? Same thing. Size. Better put screen size. So I think there you go. Alright, now I'm running, no errors. So now let's we add the necessary prep data that we have over here, the code. So let's do that. Let's see, player draw, enemy draw, so we need that, and the pointers. Okay. So let's do somewhere. Let's do it over here. So let's load our by area. So what do you have over here? Let's load human draw with our area plus height. So let's do that. So let's put your screen size. And of course, you're gonna put in, like I said before, we're gonna put the link in the description so you can do it yourself. You're gonna sec, and I think you're gonna subtract the Y object. So let's subtract player lock, which I think I have to create it. So let's, yep. So let me player lock dot b and 1. Here's enemy lock. Alright, so that's created. So let's back over here and then start that into player draw. So that's all set. So now let's look at our pointer, and remember you need to set the low by and high by order. And here it is. So this bigger than and lower than, it's going to represent your high by or low by order. So lower by and our bigger by. Remember it's in a reverse order. So here we have, and of course in the description it's going to say what you do. So here we're going to need our player graphics. So player, where our player, or this part is, plus our height, plus player size, -1. And then we're going to subtract the position. So subtract player lock and start that into player pointer. So that's it. So let's copy this, just make things faster. Delete this, subtract by 0, and player +1. So that's the next byte over. So that's our player. So just to make things easier on the eye, let me put here player draw, and then here pointer, player pointer. Do the same thing over here. And now we're gonna do the enemy part. So here is the enemy. So replace this with enemy. Just replaces this part 2. Instead of player lock, it's enemy lock. Here's enemy draw. And here is enemy pointer. And this is, take this part out. Alright, let's see. Oh, here should be enemy as well. So let me compile, assemble here, so no errors. And let's right over here, increment player lock, increment enemy lock, and as well right over here, whatever value, doesn't matter. I'm going to strobe the set player 1 so we can give ourselves some space. So let me alright, so here you have one sprite going. Let me fix whatever's happened on this enemy part. Let's see what I have wrong over here. Okay, enemy. Oh, here's should be enemy as well. So let me assemble over here. And here is our sprites moving up and down. And of course, let's go back over here. Of course, it's not 100% done, as you see on this. Where's the picture? Right over here, you see there's a close-up, they're not really aligned properly. And what the SpiceWare over here he did was he set up the left difficulty to set up video play 0 to 1 and B to 0. If you know from the Atari 2600, there's a switch to difficulty. So if you notice, as soon as you set this video, this is a video delay for player 0 to which one? I don't know if it's either 0 delay to graphics, either 0 or 1. So he delayed the video for one more, so making that so the players can align right over here. And he goes over on the next step, which is step 5, it's automatic delay. So he's gonna do this the same thing as before to set the video delay, except he's gonna do a divided by 2 position and start a temp, and then it's gonna branch if there's a delay or not over here. This let me check over here. Oh, that's the part that I was gonna say. And right before you do to the area loop that we have over here, so for example, right before this main part or a kernel part over here, he stored this right over here, because as you notice over here it's not aligned properly, so he's gonna just load this prior to the arena. And if there's a need for the delay, you're gonna go over it. You're gonna use this code over here. And of course you're gonna makes a little bit of change over here as well. And want to compensate the difference. But like I said, I'm gonna leave in the description the link for all of this. And he does have all the code right over here, so you can go over yourself. So, but that's pretty much gonna cover most of this video that you see over here. It does get a little bit big doing the spot, going over here. And as you can see, you can always use this method over here, which I believe is the flip draw. I don't really know for sure, but I know it doesn't use the line counter for this. So that's one method to use, or you can use this one, whatever you feel like it. But like I said, that's pretty much gonna be it. And if actually, so that's let me go over the video delay one more time just to make sure, because after this video you're pretty much done with the graphics, and I probably in the next video for sure gonna go over the riot shield, or the PIA, the peripheral interface adapter. So all this, the video delay, which is video delay, all it's doing is delaying the drawing of this the graphics by one line. If you come over here for VCS over here, where it is vertical delay, so just there's 1 byte, so that's how we have one line to compensate for this 2-line kernel. And it's pretty much the designers of the Atari 2600 noticed there's this the problem with starting all this update within one scan line, so they came up with this video delay that we have over here. And if you come over here on this sample 2 has a video delay somewhere right over here, just start that to delay the drawing for at least from one scale line, making sure that the sprites align with each other. So that's pretty much what the video delay does, and like I said, you can go over the rest of the material. So we have a video delay for player 0 and player 1, so you can choose which or. And like I said, with all of that said, I pretty much cover all of the sprites, all of this, the VSync video blank, WSync. This is the horizontal sync. It's done automatically, so you don't really need to. I don't see the need for it, at least. I haven't seen a good use for it, so I'm not even gonna cover it. So since the horizontal sync is done automatic. I'm sorry. We go over the null size video. Here are colors or play field and the ball and so forth. The only thing I have done here is a reflection player, and that's I can go over with the controllers when you get to that. Then you have our play fields, our reposition player. We haven't watched the audio yet, so that's a part we haven't done yet. Here's your graphics. Here's your enable our missiles or balls. Here's horizontal motion for our fine positioning. The video code delay for our players, and there's one for the ball as well. Then you have reset player missile to player 0 and so forth. So you need to let's go to, I'm gonna cover that later probably maybe for well, I'm gonna make another video at some point making a game, and I'll probably check over there. But if you notice, you pretty much cover the majority, if not of the TAE registers. Of course there's a little bit more, as you see over here, but I'm not gonna go over that for now. In the next video, like I said, I'm gonna go over probably the timers for our riot shield or riot chip or the PIA, and that's gonna be it for this video. So I know it's been a long video, and with all of that said, thanks for watching, and see you in the next one.